Our next topic is ML. Machine learning empowers systems to learn from data, making intelligent predictions and decisions and driving innovation in automation and personalization. Mr. Srini will elaborate further on this topic.
As we discussed in the previous module, artificial intelligence is a all-encompassing term that is being used now. It has two branches, the machine learning and the deep learning. We dwelled into deep learning models, especially the CNN, RNN, and artificial intelligence models in the previous module. Let's talk about machine learning branch of the artificial intelligence now. So machine learning is the way machines learn from examples and synthesize that for future data which is not been seen. So machine learning can be broadly classified into two ways. One is unsupervised learning, and the second is supervised learning. Unsupervised learning means you just provide the data to the algorithm, and the algorithm using methods, computational methods, will try to reason or group them into certain classes. So unsupervised learning is a great way to start exploring the data. You do not provide any guidance to the algorithm. Algorithm will try to group them. So types of these problems are classifying a certain thing, whether it is true or false, whether it is yes or no, or associating a group of things, whether they have relation between those, or clustering them into groups of patterns because based on their likelihood, based on their nearest neighbor and others. So these are wonderful algorithms to start the pattern recognition and discovering what's hidden in the data. And some of the examples of these algorithms are k-means clustering, c-means clustering, hierarchical association rules called a priori algorithms. These are some of the types of machine learning algorithms that are unsupervised. The other class, which is called supervised learning. So what this means is you provide a labeled set of data. That means an example data where a human will clearly mark whether this is a true or a false statement, and that data is fed to the algorithm to learn. So this is a learning phase. When you're training, there are learning and testing phase. In the learning phase, you feed the labeled data telling that it is false or true, it is yes or no, whether it is the right outcome. And the algorithm learns from the labeled data, and when you pass an unlabeled data, it will classify. Like if you train the model to tell whether it's a dog or a cat, and you label and supply examples and it will train on them, and you provide an unlabeled image and it will try to classify it into one of these two labels. So types of problems that it typically solves are called regressions or classification, which is basically whether it is yes or no, whether it belongs truth or false, those kind of thing. And these algorithms require labeled data to be effective. So some of the popular algorithms are linear regression, logistic regressions, support vector machines, k-nearest neighbors, and such that. There is a reinforcement learning and active learning, which we covered as part of AI. That's also one of the broader machine learning algorithmic type that we use. Now, supervised learning, as we mentioned, uses labeled data and it requires human curated information. It provides high accuracy and it is in widespread use in various industries. Unsupervised data is used to categorize the data into clusters and without labels. It is effective but may not achieve the same accuracy as supervised learning. Usually, when you start with an exploration of a data, you start with an unsupervised learning first, trying to understand the pattern, trying to understand the clusters or the groups within that. And once you learn, then you classify some of those groups by human labeling and then supply that to a supervised learning algorithm as a second step. This method is called ensemble learning. Ensemble is basically you have one algorithm that works on the data. Output of that algorithm is fed into the second algorithm, and that works on more. So these ensemble learnings are complex ways of assembling multiple different algorithms into a workflow and achieving the business results. So these are widely used across the industries. Classification problems, recommendation engines, what all those are the predictive models that are part of the machine learning universe. So machine learning and artificial intelligence go hand in hand. They use similar technologies, similar uses. One key difference is most of the deep learning artificial intelligence, or the neural networks as we call, they require GPU to be very effective, whereas most of the machine learning models can run on CPUs. However, their utility is in a different area where you can understand where a customer fits in, which group one particular object falls in, and all those. Whereas deep learning will go beyond and has much more usages. So each one are used in different areas of a problem solving, and both of them are needed current industry.